Hey everybody, so we're starting a new chapter, and this chapter is going to be focusing on inequalities, and it's going to be very similar to equalities where you have an equal sign, except there's going to be a few minor catches. So in this first lesson, we're going to be talking about solving and graphing single-step inequalities. So all this is just solving equations, except there's one minor catch to it. So think back to our process for solving equations, making our t-chart, get our variable on one side, get our numbers on the other side. So in order to solve and graph inequalities, we need to talk about how we graph inequalities. So up here on the board, I'll move it in a little bit. I've got the graphs of some basic inequalities. So the first one is x is less than or equal to 0. And that's how you would say it, x is less than or equal to 0. Now to graph that on a number line, because you're going to have to be able to graph these on a number line, it would be a closed circle on the number, so a closed circle on 0. And then since it's all of the x values that are less than or equal to 0, we would shade it to the left. Now sometimes you'll see it where it's shaded on the actual number line like this. Sometimes it'll be above it like this, where it'll be above the number line. I prefer going above the number line so that way it's easier to see, but you might see it both ways. So when it's less than or equal to, we've got a closed circle. If it's just less than, then it's an open circle because we're not including zeros, just the values that are less than 0. So an open circle shaded to the left. Same thing with greater than or equal to, closed circle because it's the or equal to part, and then shaded to the right. Greater than 0, open circle, shaded to the right. So what we're going to work on is practicing solving equations, or solving inequalities, I should say, where once you get down to it, you'll get an answer like this, and you'll have to be able to graph it on a number line. So this one says, write and graph the inequality that represents the situation. And the situation is, in order to ride Superman at Great America, the rider's height must be more than 54 inches. So we're looking in this statement. What is the statement telling us? Well, the statement is telling us that the height is more than 54. So I'm going to go ahead and translate that. For height, we don't know what the height is, but we have some options. So I'm going to leave it as h. More than, it has to be more than, so it's got to be greater than 54. It can't be greater than or equal to because it has to be strictly more than 54. So if we put this together, we've got h is greater than 54. So on a number line, if we were to graph it, I might cancel this out and put 54 in the middle. Open circle on 54, shaded to the right. So all it is translating the statement into an inequality. Now we're going to go the opposite way. We're writing an inequality based on the graph. So on the graph here, we've got a closed circle on 4, shaded to the left. So are all of the numbers that are shaded less than 4 or greater than 4? So on the graph, they are less than 4, which means that x has to be less than 4. But since it's a closed circle, we also know that it can be less than or equal to 4. Down here, we've got another graph. We've got an open circle on -6, shaded to the right. So again, are all the numbers shaded greater than -6 or less than -6? All these numbers are greater than -6. So we've got x is greater than -6. And since it's an open circle, it's just greater than, not greater than or equal to. All right, when you are solving inequalities, you do the same steps that you would take to solve a normal equation, except for there's one catch, and make sure you write this catch down. Whenever you multiply or divide both sides by a negative, you need to flip the inequality. For example, I've got 2x is less, or negative 2x is less than 6. So same steps I would take normally. Try to get x by itself. I would divide by negative 2. Since I divided both sides by a negative, this less than flips and becomes x is greater than negative 3. So on a number line, we would have negative 3 in the middle, open circle, shaded to the right. Same thing over here. We've got x over negative 3 is greater than 2. In order to solve this, we have to get x by itself, so we multiply both sides by negative 3. Cancels out, and we get x is less than, because we multiplied both sides by a negative, negative 6. So on a number line, we might put negative 6 in the middle, open circle, shaded to the left. So if you multiply or divide both sides, if you have an equation where you have to simplify and in one of the sides you multiply by a negative, you don't flip the signs. It has to be both sides multiplying or dividing by a negative. All right, so we're going to solve some simple equations here and then work up to some more difficult ones. We've got x minus 9 is less than or equal to 3. Okay, so I'll move back over here. So same steps we would take to solve a normal equation. We got to get x by itself, so we're going to add 9 to both sides. X is less than or equal to 12. And now all we have to do is graph it on the number line. Now, this one is a little bit off, so I'm actually going to see if I can delete the numbers underneath. And I might put negative, or I might put 12 right here. So this one would be 11, 10, 9, 8, 7, 13, 14, 15, dot, dot, dot. And we're looking for less than or equal to 12, which would mean a closed circle on 12, shaded to the left, because we want the numbers less than that. Next one, we've got negative 6 is greater than or equal to m plus 1/2. So in order to solve this one, we have to subtract 1/2 from both sides. Negative 6 minus 1/2, well, we can just say that's negative 6.5 is greater than or equal to m. Now, a lot of times people get confused because m is on the other side. So what you can do is you can flip everything. You can put m on the left, flip the inequality, and put the number on the right, so that way it's a little bit easier to read. M is less than or equal to negative 6.5, so I'm going to put a closed circle on negative 6.5. Now, keep in mind, negative 6.5 is between negative 6 and negative 7, not negative 5 and negative 6, because it's negative 6 and then a half negative more. Closed circle, shaded to the left. All right, last one down here at the bottom, we got x over 4. Let's see if I can make it bigger. X over 4 is less than or equal to negative 1. In order to solve this one, I need to multiply both sides by 4. Now, even though this side has a negative multiplied by a positive, we're multiplying both sides by a positive, so that sign stays the same. It's still x is less than or equal to negative 4. So I'm going to put a closed circle on negative 4, shade it to the left. All right, a couple more here. We've got 42 is greater than or equal to negative 6z. So in order to solve this one, we got to get z by itself. So we're going to divide both sides by negative 6. Since we divided both sides by a negative, our inequality flips. So we get z is, we got the inequality flip there, and this becomes negative 7. Now, again, like I told you guys, if the variable is on the right side, good practice, flip it so that way it's on the left. So z is greater than or equal to negative 7. So on the number line, we put a closed circle on negative 7 and shade it to the right. Last one down here, we've got y over 4, over negative 4 is less than 3.25. So to solve this one, we have to multiply both sides by negative 4. Since we multiply both sides by a negative, we have to flip the inequality. So y is greater than 3.25 times negative 4 is negative 13. So y is greater than negative 13. So maybe I'll put negative 13 right here. Open circle, shaded to the right. So really, it's the same process as solving a normal equation. It's just that one catch, where if you multiply or divide both sides by a negative, you have to flip it, and then figuring out the graphing part. All right, so now what we're going to do is we're going to translate a sentence and then solve it. So this first one says the sum of 13 and a number is at least 24. So 13 and a number. So keywords sum and at least. Sum tells us that we need to add. At least tells us it has to be greater than or equal to. It has to be at least equal to, hopefully greater than. Sum of 13 and a number t. So 13 plus t is at least greater than or equal to 24. And then all I have to do is solve that. Subtract 13 from both sides. T is greater than or equal to 11. And then plot it on a number line. So closed circle on 11, shaded to the right. All right. The difference of y and 12 is no more than 5. Keyword difference, no more than. So it has to be less than or equal to 5. So the difference of y and 12, y minus 12, has to be less than or equal to 5. To solve that one, I would add 12. Y is less than or equal to 17. Which means that I would have a closed circle on 17, shaded to the left. All right, down here at the bottom, the product of a number t, of 8 and a number t is more than negative 20. So keywords, product, keyword more than, product means times, more than is greater than. So the product of 8 and t is more than negative 20. To solve this one, I would have to divide both sides by 8. T is greater than negative 20 divided by 8. Let's reduce that as a fraction. If I divide both sides by 4, I get negative 5 over 2. So let's put negative 5 over 2 right here. Put it in between because it's a fraction. and open circle shaded to the right. All right, next one, the quotient of x and -3 is less than 9. So keywords, quotient and less than. What operation is quotient? It is division. And less than is just the less than symbol. So quotient of x and -3. So x divided by -3 is less than 9. So in order to solve this, I have to multiply both sides by -3. When I do that, I have to flip the inequality. So x is greater than -27. So I'm going to put a open circle on -27, shaded to the right. We're going to skip that one, go right to the perimeter one. So this one says write and solve an inequality to find the possible values of x. So it says that the perimeter has to be greater than 23.8 centimeters, and we've got this shape here. First of all, how do you find the perimeter of a shape? We would add all the sides. So to add all the sides, well, this side is x. So we've got x plus 6.2 plus 6.2 plus 4.9. And it has to be greater than 23.8. Greater than 23.8. Now all I need to do is solve to find my missing side x. So I'm going to add all of those together. I've got 6.2 plus 6.2 plus 4.9 is going to give me x plus 17.3 is greater than 23.8. Then I just need to subtract 17.3 from both sides. And x is greater than, this is 5, this is 6.5. So in order for the perimeter to be greater than 23.8, x has to be greater than 6.5 centimeters. So same steps that you would take to solve a normal equation, just one minor catch to it, and then we just need to make sure that we know how to graph these. Now, this is going to be kind of an easier example. We're going to kick it up a notch and solve more difficult inequalities. And then we're actually going to use this to graph inequalities. And you'll see why graphing is a little bit different. If you did the chapter 4 introduction on Desmos, you've probably already noticed that inequalities create a shading pattern on the graph. So that'll come into play in the next few classes.